Subscribe to my channel and press the bell icon for the latest video updates. Hello everyone, welcome to my channel on Learning Field. Today we are going to derive the equation for series and parallel combination of the capacitor. So let us start. So let us draw the diagram of series combination. This is the diagram for series combination. This is capacitor C1 and this is capacitor C2. This is charge Q and this one is charge Q. Let the electric potential be V1. This is electric potential V1. This is electric potential V2. Since we are going to derive the equation, and let this point be V. One point you need to note down that since we know that in this is very important point you need to note down, since in series combination what happens in series combination charge remains constant. You have already seen charge is q here also, and here also charge is q. So in series combination what happens? Charge remains constant. So let us derive the equation for series combination of the capacitor. Since we know that total, this is the electric potential, this is potential difference V, isn't it? We know that total potential difference is equals to what? V1 plus V2. We know that V is equals to V1 plus V2, isn't it? Total potential. If you want to find the total, we need to add 2 also, isn't it? V1 plus V2. So we need to find the total potential. Therefore, total potential in the circuit will be equals to V is equals to V1 plus V2. So we can write, since we know that V is equals to what? V is equals to Q by C. From how you got the formula? Electric potential equals to charge by capacitance or capacitor. How you got the formula? We know that charge is equals to what? Charge is equals to capacitance into electric potential. This is the equation we already derived. We also know that charge is equals to capacitance or capacitor into electric potential. We already derived this formula. So let us substitute this here. So V is equals to what? Q by C. We are substituting the value of electric potential V, which is equals to Q by C. So V1 will be equals to what? In the case of V1, the charge is Q and capacitance is C1. So let us substitute. Charge is Q and capacitance is C1 plus charge is Q, capacitance is C2, which is equals to Q by C. Now you can take the common of these two easily, isn't it? Q. So let us take the common. 1 by C1 plus 1 by C2, which is equals to, now let us cut this one, Q and Q. Then what remains? 1 by C is equals to 1 by C1 plus 1 by C2, isn't it? This is the expression we required for capacitance of a. Now we are going to prove for parallel combination. So let us derive the equation. We know that in parallel combination the circuit diagram is how. So let us draw the circuit diagram first, and we know that in parallel combination the capacitor is connected in this way. So This is the required diagram for the parallel combination of the capacitor. So let us name them. Suppose this is charge Q1, this is charge Q2, and this is charge Q3. And this one is capacitance C1, capacitance C2, and capacitance C3. Now the potential, now the potential difference between the electric circuit will be V. Okay, and one important points you need to note down that in parallel combination, what happens in parallel combination? In parallel combination, potential difference remains constant. This is the point you need to note down. What happens that in parallel combination the potential difference remains constant. What happens in series combination? In series combination the charge remains constant, isn't it? The charge was constant. In parallel combination it was the potential difference that remains constant. So let us derive. We know that the total charge will be what? Similarly we have done for the series combination, total charge will be Q is equals to Q1 plus Q2. Okay, and we have 3 charge, isn't it? So plus Q3. So we can similarly we can substitute the values similarly what we have done in the series combination. We know that Q is equals to C into V, charge is equals to capacitance into potential difference. So we can directly substitute it. So Q is equals to C into V, which is equals to, here the charge, for the charge Q1 the capacitance is C1 into V plus C2 into V. For Q2 is C2 plus for Q3 it is C3. So that means C3, okay, C3 into V. So similarly we can take the V common here. C into V is equals to V common. If you will take V common, then what remains here? C1 plus C2 plus C3. We have taken V common from each, then what remains? C1 plus C2 plus C3. So now we can that means we can cut V and V. So C is equals to C1 plus C2 plus C3. This one is the required expression for parallel combination of capacitor. So this is the important formula you need to note down. If I explained in Hindi, then it will be easy to understand for you, isn't it? So let us start. इन सीरीज कम्बिनेशन में क्या हुआ? सीरीज कम्बिनेशन हमने डायग्राम ड्रॉ कर लिया और चार्ज क्या होता है? सीरीज कम्बिनेशन कांस्टेंट रहता है और कैपेसिटेंस C1, कैपेसिटेंस C2, पोटेंशियल डिफरेंस चेंज होता रहता है. सो पोटेंशियल क्या होगा? V1 प्लस V2. टोटल पोटेंशियल क्या होगा? V1 प्लस V2. ये हमने लिखा. सीरीज कम्बिनेशन क्या है? कांस्टेंट रहता है, चार्ज कांस्टेंट रहता है. यही याद करना चाहिए और सब इजी है. सो टोटल पोटेंशियल इन द सर्किट V इज इक्वल्स टू V1 प्लस V2. और हमने क्या किया? V के जगह में हमने Q/C को बैठाया. फॉर्मूला है कि चार्ज क्या होता है? कैपेसिटेंस इनटू इलेक्ट्रिक पोटेंशियल होता है. सो हमने क्रॉस मल्टीप्लाई किया और V का वैल्यू उठाया तो Q/C, V इक्वल्स टू Q/C हमने निकला है. सो हमने सब्सटीट्यूट कर दिया और हमें पता है कि V1 की जगह में क्या कैपेसिटेंस C1 है और चार्ज Q है. सो हमने सब्सटीट्यूट किया. द वैल्यूज हमने क्या मिला? 1/C इक्वल्स टू 1/C1 प्लस 1/C2. ये हुआ सीरीज कम्बिनेशन के लिए. और पैरेलल कम्बिनेशन के केस में क्या हुआ? पोटेंशियल डिफरेंस क्या होता है? कांस्टेंट रहता है. तो हमने पोटेंशियल डिफरेंस कांस्टेंट रहता है तो हमने डायरेक्टली फॉर्मूला को अप्लाई किया. फॉर्मूला में है कि Q इक्वल्स टू क्या होता है? हमने जाना कि चार्ज, यहाँ पर चार्ज तो क्या होता है? चेंजेस रहता है. सो हमने क्या किया? Q इक्वल्स टू Q1 प्लस Q2 प्लस Q3. हमें पता है कि टोटल चार्ज क्या होगा? टोटल चार्ज यहाँ पर लिख देना चाहिए. टोटल चार्ज क्या होगा? टोटल चार्ज Q इक्वल्स टू Q1 प्लस Q2 प्लस Q3। हमें पता है कि टोटल चार्ज क्या होगा, Q1 प्लस Q2 प्लस Q3। सो हमने डायरेक्टली सब्सटीट्यूट कर दिया इस वैल्यू को। सब्सटीट्यूट करने के बाद हमने पता चला कि Q1 क्या होता है, C1 इंटू वी, और Q2 क्या होता है, C2 इंटू वी, और Q3 क्या होता है, C3 इंटू वी। यहाँ पर पोटेंशियल डिफरेंस रिमेंस कांस्टेंट, दैट मतलब पोटेंशियल डिफरेंस वो कांस्टेंट रहता है, वो चेंज नहीं होगा। इसलिए हमने डायरेक्टली वैल्यू को पुट कर दिया और हमने सोल्यूशन में क्या मिला, एक्सप्रेशन CS इक्वल्स टू C1 प्लस C2 प्लस C3। ये हुआ हमारा रिक्वायर्ड एक्सप्रेशन, और इस एक्सप्रेशन को हमें न्यूमेरिकल्स में भी चाहिए, इसलिए हमें ये एक्सप्रेशन याद करना चाहिए। आज के लिए इतना ही समाप्त, और नेक्स्ट डे हम चैप्टर 3 पढ़ेंगे, करंट एंड इलेक्ट्रिसिटी। और अभी तक सब्सक्राइब नहीं किया मेरे चैनल को तो सब्सक्राइब कर लीजिएगा। थैंक यू।